just going over the what are we doing? Back scripting, right? Just going over back scripting. What first thing I did was just write my script. Army cat out. Hey world first. So from the script here you can see yeah. So I began with shebang. That is pound exclamation mark bin bash. I began writing the script with shebang, and anything that comes in front of the pound sign, that is just a comment about the code, and I just put just saying hi to the world. So the first line is echoing what is your name. So the first thing that will be executed is just what is your name will be showing up, and then after that I would read an answer. That is the read variable is just is to get the input from the user, just to get an interaction. And once you put the answer, it will echo out hello there, and then dollar sign answer. This dollar sign will refer back to whatever the user or whatever the person puts. You know, when prompt when prompted to get an answer from. So for instance, we run Hey World again. It brings up what is your name, and then let's say Johnny the man. Boom. And as soon as we enter, it says hello there, Johnny the man, and that is basically my first batch scripting that I just wrote. And if I had actually hold on. So if I had put tag P, it would prompt the user for any input. If I had put tag SP, it would have been silent. S makes the user input silent, so it won't show in the terminal. That's usually getting credentials from the user. But yeah.
else, and if statements. Conditional statements allow us to perform different actions based on different conditions. The most common conditional bash statements include if, else, and if. The if statement is relatively simple. It checks to see if a condition is true, but it requires a very specific syntax. Pay careful attention to the syntax, especially the use of required spaces. In this example, if some test evaluates as true, the script will perform an action, or any actions between then and fi. Let's look at an actual example. In this example, we use an if statement to check the age entered by a user. If the entered age is less than 16, the script will output a warning message. Now, let's make the script executable and try it out. Great, our age check is working correctly. The square brackets we used in the if statement are actually a reference to the test command. This means we can use all the operators that are allowed by the test command. Refer to your lab guide for a list of some of the available operators. With this in mind, our previous example using if can be rewritten without square brackets as follows. Even though this example is functionally equivalent to the one using square brackets, the square brackets make the code slightly easier to read. We can also perform a certain set of actions if a statement is true and another set if it is false. To do this, we can use the else statement, which has the following syntax. Let's extend our previous age example to include the else statement. In this script, if the entered age is 16 or over, a welcome message will be displayed. Let's run this script and make sure it works as expected. Notice that the else statement was executed when the entered age was greater than, or more specifically, not less than, 16. The if and else statements allow only two code execution branches. We can add additional branches with the elif statement, which uses this syntax. Let's extend our age example again to include the elif statement. In this example, the code execution flow is slightly more complex. In order of operation, the then branch executes if the entered age is less than 16, the elif branch is entered, and the hats off message displayed if the age is greater than 60, and the else branch executes only if the age is greater than 16 but less than 60. Let's try this latest script and see if it works. Great. Now we have a firm grasp on conditional statements in Bash. If, else, and elif statements. Conditional statements allow us to perform different actions based on different conditions. The most common conditional bash statements include if, else, and elif. The if statement is relatively simple. It checks to see if a condition is true, but it requires a very specific syntax. Pay careful attention to the syntax especially the use of required spaces. In this example, if some test evaluates as true, the script will perform an action, or any actions between then and fi. Let's look at an actual example. In this example, we use an if statement to check the age entered by a user. If the entered age is less than 16, the script will output a warning message. Now, let's make the script executable and try it out. Great, our age check is working correctly. The square brackets we used in the if statement are actually a reference to the test command. This means we can use all the operators that are allowed by the test command. Refer to your lab guide for a list of some of the available operators. With this in mind, our previous example using if can be rewritten without square brackets as follows. Even though this example is functionally equivalent to the one using square brackets, the square brackets make the code slightly easier to read. We can also perform a certain set of actions if a statement is true and another set if it is false. To do this, we can use the else statement, which has the following syntax. Let's extend our previous age example to include the else statement. In this script, if the entered age is 16 or over, a welcome message will be displayed. Let's run this script and make sure it works as expected. Notice that the else statement was executed when the entered age was greater than, or more specifically, not less than, 16. The if and else statements allow only two code execution branches. We can add additional branches with the elif statement, which uses this syntax. Let's extend our age example again to include the elif statement. In this example, the code execution flow is slightly more complex. In order of operation, the then branch executes if the entered age is less than 16, the only 2 code execution branches. We can add additional branches with the elif statement, which uses this syntax. Let's extend our age example again to include the elif statement. In this example, the code execution flow is slightly more complex. In order of operation, the then branch executes if the entered age is less than 16, the elif branch is entered, and the hats off message displayed if the age is greater than 60, and the else branch executes only if the age is greater than 16 but less than 60. Let's try this latest script and see if it works. Great. Now we have a firm grasp on conditional statements in Bash. Boolean logical operators. Boolean logical operators like and or are somewhat mysterious because Bash uses them in a variety of ways. One common use is in command lists, which are chains of commands whose flow is controlled by operators. The pipe symbol is a commonly used operator in a command list and passes the output of one command to the input of another. Similarly, Boolean logical operators execute commands based on whether a previous command succeeded, meaning it returned true or zero, or failed by returning false or non-zero. Let's take a look at the AND operator first, which executes a command only if the previous command succeeds or returns true or zero. In this example, we first assign the username we're searching for to the Boolean logical operators. Boolean logical operators like and or are somewhat mysterious because Bash uses them in a variety of ways. One common use is in command lists, which are chains of commands whose flow is controlled by operators. The pipe symbol is a commonly used operator in a command list and passes the output of one command to the input of another. Similarly, Boolean logical operators execute commands based on whether a previous command succeeded, meaning it returned true or zero, or failed by returning false or non-zero. The output of one command operator in a command list and passes the output of one command to the input of another. Similarly, Boolean logical operators execute commands based on whether a previous command succeeded. Meaning it returned true or zero, or failed by returning false. Or non-zero. Let's take a look at the AND operator first, which executes a command only if the previous command succeeds or returns true or zero. In this example, we first assign the username we're searching for if the previous command succeeds or returns true or zero. In this example, we first assign the username we're searching for to the user2 variable. Next, we use grep to check if a certain user is listed in the etc password file, and if it is, grep returns true and the echo command is executed. Now, let's try it with a condition that returns false. When we try searching for a user that we know does not exist in etc password, grep returns false and our echo command is not executed. When used in a command list, the OR operator is the opposite of AND. It executes the next command only if the previous. When we try searching for a user that we know, does not exist in etc password, grep returns false and our echo command is not executed. When used in a command list, the OR operator is the opposite of AND. It executes the next command only. if the previous command failed, meaning it returned false or non-zero. In this example, we took our previous command a step further and added the OR operator, followed by a second echo command. Now, when grep does not find a matching line and returns false, the echo command after the OR operator is executed instead of the one after AND. These operators can also be used in a test to compare variables or the results of other tests. When used this way, AND combines two simple conditions, and if they are both true, the combined result is success, returning true or zero. Consider this example. In this example, we use AND to test multiple conditions. And since both variable comparisons are true, the whole if line succeeds, so the then branch will be executed. We'll make this script executable and run it to see if our logic is sound. It appears to have worked. Great, let's move on to the OR operator. When used in a test, the OR operator is used to test one or more conditions, but only one of them has to be true to count as a success. Let's look at an example. In this example, we use OR to test multiple conditions. Let's give it a try. Since one of the variable comparisons was true, the whole if line succeeded. So the then branch executed. Loops. In computer programming, loops help us with repetitive tasks that we need to run until a certain criteria is met. In Bash, the two most predominant loop commands are for and while. We'll examine both. For loops. For loops are very practical and work very well in Bash one-liners. This type of loop is used to perform a given set of commands for each of the items in a list. Let's briefly inspect its general syntax. The for loop will take each item in the list in order, assign that item as the value of the variable var name, perform the given action between do and done, and then go back to the top, grab the next item in the list, and repeat the steps until the list is exhausted. Let's take a look at a more practical example that will quickly print the first 10 IP addresses in a given subnet. In this Bash one-liner, we use the seq or sequence command to print a sequence of numbers, in this case the numbers 1 through 10. Each number is then assigned to the IP variable, and then each IP address is displayed to the screen as the for loop runs multiple times, executing at the end of the sequence. Another way of rewriting the previous for loop involves brace expansion using ranges. With brace expansion using ranges, we supply the first and last values of the range. This can be a sequence of numbers or characters. This is known as sequence expression. There's a lot of potential for this type of loop. Displaying IP addresses to the screen may not seem very useful, but we could use the same loop to ping each IP address, run a port scan using nmap, etc. While loops. While loops are also fairly common and execute code while an expression is true. While loops have a simple format and, like if statements, use square brackets for the test. Let's re-examine the previous example and rewrite it using a while loop. Our script gives the counter variable the initial value of 1, then as long as the counter variable is less than 10, the IP address is printed to the screen. Let's run this script and see what we get. This is not the output we expected, and it's due to a common mistake called an off by 1 error. In our script, we use the less than operator, -lt, instead of less than or equal to, -le, so our counter only got to 9, not 10 as originally intended. The counter ++ line uses the double parenthesis construct to perform arithmetic expansion and evaluation at the same time. In this particular case, we use it to increase our counter variable by 1. Fixing our script requires one minor change. We simply need to change it to use the less than or equal to operator. Good. Our while loop works quite well now. Functions. In terms of Bash scripting, we can think of a function as a script within a script, which is useful when we need to execute the same code multiple times. Rather than rewriting the same chunk of code over and over, we can write it once as a function and then call that function as needed. Put another way, a function is a subroutine or a code block that implements a set of operations, a black box that performs a specific task. Functions may be written in two different formats. The first format is more common to Bash scripts. The second format is more familiar to C programmers. The formats are functionally identical and are a matter of personal preference. Consider this simple example. In this script, we declare a function called printMe that simply echoes a line to the screen. We then call the function by its name to execute it. Functions can also accept arguments. In this case, we pass a random number into the function, which outputs it as $1, the function's first argument. Note that the function definition contains parentheses. In other programming languages such as C, these would contain the expected arguments, but in Bash, the parentheses serve only as decoration and are never actually used. Also note that the function definition must appear in the script before it's called. Logically, we can't call something we haven't defined. Let's run this script to verify that it works. In addition to passing arguments to Bash functions, we can return values from them as well. Bash functions don't actually allow you to return an arbitrary value in the traditional sense. Instead, a Bash function can return an exit status, like 0 for success and non-zero for failure, or some other arbitrary value that we can later access from the $? Global variable. Alternatively, we can set a global variable inside the function or use command substitution to simulate a traditional return. This basic example returns a random number into $? Notice that a random number is returned every time we run the script. This is because we returned the special global variable $random into $? If we use the return statement without the $random argument, the exit status of the function, which is 0 in this case, would be returned instead. Now that we have a basic understanding of variables and functions, we can dig deeper and discuss variable scope. The scope of a variable is simply the context in which it has meaning. By default, a variable has a global scope, meaning it can be accessed through the entire script. In contrast, a local variable can only see within the function, block of code, or subshell in which it is defined. We can overlay a global variable, giving it a local context by preceding the declaration with the local keyword, leaving the global variable untouched. Let's see how local and global variables work in practice with a simple example. Let's highlight a few key points within this code. First, note that we declare two global variables, setting name1 to John and name2 to Jason. Then we define a function, and inside that function, declare a local variable called name1, setting the value to Edward. Since this is a local variable, the previous global assignment is not affected. Name1 will still be set to John outside this function. Next, we set name2 to Lucas. Since we did not use the local keyword, we are changing the global variable, and the assignment sticks both inside and outside of the function. Let's run this script to see it in action. Based on this example, we know that changing the value of a local variable with the same name as a global one will not affect its global value. We've also verified that changing the value of a global variable inside of a function without having declared a local variable with the same name will affect its global value. Practical examples. So far, we've covered the basics of Bash scripting. Let's put together all the concepts we've discussed and walk through a few practical examples. Practical Bash usage. Example 1. In this example, we want to find all the subdomains listed on the main megacorp1.com webpage and find their corresponding IP addresses. Doing this manually would be frustrating and time-consuming, but with some basic bash commands, we can turn this into an easy task. We'll start by downloading the index page with wget. Manually scanning the file, we see many lines we don't need. Let's start narrowing in on lines that we need and strip out lines we don't. First, we can use grep to extract all the lines in index.html that contain HTML links by searching for href equals. This beta subdomain is a prime example of what we're looking for. Now, let's use grep to grab lines that contain .megacorp1, indicating the existence of a subdomain, and grep-v to strip away lines that contain the boring www subdomain we already know about. This output looks closer to what we need. By reducing our data in a logical way and making sequentially smaller reductions with each pass, we're in the midst of the most common cycle in data handling. It looks like each line contains a link and a subdomain, but we need to get rid of the extra HTML around our links. There are always multiple approaches to any task performed in Bash, but we'll use a little-known approach for this. We'll use the -F option of awk to set a multi-character delimiter, and we'll set our delimiter to http://. We then tell awk we want the second field, or everything after our delimiter, returned. The beginning of each line in our output shows that we're on the right track. Now we can use cut to set the delimiter to a / and print the first field, leaving us with only the full subdomain name. If we were to criticize our work in an effort to improve, which we should always do, we might see some simple ways to streamline this exercise. First, we began our search with href equals and later searched for http://. These are both essentially links, but this requires that every line contain both strings. If a line only had one of these strings but not both, we would have missed it. Redundancy like this should be avoided, especially when working with large files. In addition, we don't necessarily care about links. We're looking for subdomains ending in .megacorp1.com, regardless of whether or not the reference is contained in a link. A well-formed regular expression search can handle this scenario easily. This solution is quite compact, but it introduces some new techniques. First, notice the grep-o option, which only returns the string defined in our regular expression. The expression itself looks complex, but it's fairly straightforward. The string we're searching for is wrapped in single quotes, which, as we mentioned, will not allow variable expansions and will treat all enclosed characters literally. The first block in the expression is a negated set that searches for any number of characters not including a /. Notice that periods are escaped with a / to reinforce that we are looking for a literal period. Next, the string must end with .megacorp1.com. When grep finds a matching string, it will carve it from the line and return it. Now we have a nice, clean list of domain names linked from the front page of megacorp1.com. We could have done more with this regular expression, but it's a great start and a good example of why regular expressions are so valuable. Next, we'll use the host command to discover the corresponding IP address of each domain name in our text file. We can use a bash one-liner loop for this. The host command gives us all sorts of output, and not all of it is relevant. We'll extract the IP addresses by piping the output into a grep for has address, then cut the results and sort them. Nice. We've extracted the .megacorp1.com subdomains from the web page and obtained the corresponding IP addresses.
Back at it again. It was a good session today. I think we did an hour. Can you zoom in your screen? Oh man, sorry bro. I'm just seeing at it. I'm just taking a look at it. I'll try to get it fixed. I'll be sharing this videos or the actual video of my Cali box. The windows I will share it whenever I'm ready, and especially just going through like every detail or every room. I will be doing like try-hack me rooms, so just tune in then. But I can't really. I'm using my personal computer, so I don't want to kind of share too much, especially like with my IP address and stuff. So that's why I'm not really trying to zoom in there. Because if I go out right now, I have like my other files up running. Those are some personal stuff, so I can't really zoom in right now. But this video is just to motivate people to, study too. So it's not really. I'm not trying to teach you guys how to work or how to actually pass the exam. I'm not, going through the lesson chapter by chapter because I hope you guys already have the materials to go over them. But this is just to motivate people that to get up every morning and study for at least 30 minutes to 1 hour, and that's all you need to get by. But yeah, I'll try to zoom in if this is the only windows I have up on this screen. I don't mind just zooming in so you guys could follow along, but as of like sharing the whole screen and making it big, I just can't do it because I'm using my personal computer. But for today, it was a good session. I think we did an hour and 20 minutes, so 25 minutes. And it's about to be like almost 10 o'clock, 11 o'clock, right? So let's go back and got the whole work to do. So, but it's a good start for the day, today, Thursday. As always, we got to end it with some good music, good vibes, and then we back at it again tomorrow. But I'll talk to you guys later. Keep it cool. Make sure y'all study, but relax, stay happy.
Mi cuero en PR, todas las yales, la mía se roba el show si sale. Quieren ser yo, pero no le salen. Que ay, santo, Dios mío, casi cale. En RD tanto mi cuero en PR, todas las yales, la mía se roba el show si sale. Ay, salen que ay, santo, Dios mío, casi cale. 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 En RD tanto mi cuero en PR, todas las yales, la mía se roba el show si sale. Quieren ser yo, pero no le salen. Casa de campo Chucky en México ando bélico. Vivo cosmético, que pata encima, no me le estima. Bajen la luz y cierren la cortina. Que no quiero video, estoy harto de la foto. Estoy harto de todo el mundo, menos ese toto, ese toto. Ey, ey, botella de champaña.
In the love, tell them some dream of a boss. Real God, pull up a prospect with a new tech. Teach them a lesson like you tech. New Intratech, new document. Reach you on my yard. New girl become a stress. Host a new big bird, the internet. See me enemy squeeze it, a tree connect. We'll leave a blood, I'll leave your neck. Sugar wouldn't just me stop the breath.
Yo,
yeah, run water. Real bad man send them as me rep. Them a offer me treat me don't regret. Tell them some dream of a boss. Tell them some dream of a boss. Who we take for your girl get the cost. Tell them some dream of a boss.
I don't know what's
what's happening in here. Ricky Toronto in the building. What's going on? Hey, yo. We in the DR right now.
Yo no voy con tu sistema, nadie le cojo panchata desde los 14 haciendo delitos sin mentir. No me pueden faltar porque si faltan se les da su cocotazo. Ya no son tiempos de niños, ya son tiempos de sicarios. Las que eran de bonito, ahora son de hierro, no jugando. La prendemos de apertura el bloque, lo representamos.
Andamos en detones, llegó el que te la quita, te la pone. El que no necesita, pero te follo sin condón. Y te la aplico, cogiendo los fones en este disco. Esta es la vieja con la nueva 100 y pico. Sigo el perico en toda la esquina como un chito. Y tú sigues de tonto como Jaimito. Yo no soy leyenda, un ejemplo de barrio, el chamaquito. Y tú sigues en cabeceo y yo matando en este disco. Vamos para la 30, para la 30, para la 30. Nos vamos para la 30, para la 30, para la 30. Nos vamos para la 30, para la 30, para la 30. Nos vamos para la 30, para la 30, para la 30.
Yo, yo.
Para la 30, 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 para la 30.
That word is in the dictionary, huh?
I am so obsessed. I want to chop your body. I want it if I can see. When I make I see. You're my love, man, see. Let me make it balance.
Big vibe tonight. What we doing? How we feeling?
My baby, my Valentine. Can I hear the Ricky with the birds and the birds? If you leave me, I could die. I swear. You are like the oxygen I need to survive. I'll be honest. Your love ain't it, totally me. I am so obsessed. I want to chop your body. I want it if I can see. When I make I see. You're my love, man, see. DJ Puppy.
I'm trying to keep up with what's going on.
You could be my partner, never ride it solo. And we can do I'm low, you don't need to party. I'm feeling what you're doing, oh yeah, baby, carry go.
The guitar is not coming back. The guitar's not coming back. But we can bring back the piano. We can bring back the piano.
Hey. See every carnival, Johnny. You don't know be nice and temperature they rise. If you leave me, I go die. I swear, you are like the oxygen I need to survive. I'll be honest. You know the road is calling me. I am so obsessed, but all I left with is a memory. Monday, I see we getting on the street. Tuesday, rough pretty girl and repeat. Wednesday, everybody head to the beach. So come make me jump and sing. Oh, Lord.
What's this talk in the chat now? What's going on? What we talking about?
This one I got you, baby, ja. I know get time, I did that. Dada cover my face, calling me da. Biggie man, we do the yeah, da. Tell me, what's it going? You are good, all the best. The girl, ride the foot. I know feet, die for nothing. What's it going? You are good, all the best. The girl, ride the foot. I know feet.
Stacking up my money, no time for your shit. Money kulako, I don't care for your hate. Me no fighting. Throwing down drums from bungalow out there. I did my penthouse, you can't even reach me. Me no frightened. It is not your fight, stand down. I'm not the one, calm down. You know I'm not your problem. You can't be me, rival.
If you see a live stream that's gone, it means the copyright police took it down. Simple.
Bow down. To bambino parabale. Oboya ko lari mole. Okay. It's okay, let them see. Trouble no they pay me. Kinjaye on a daily. Okay. We go to okay. I just want that. This is the remix. Your body calling me, and I let oh my baby, show my baby daily. Your booty body, they make a bad man cake. I want to know, can I fly you out and give you some love? I want to know, yeah. You speak your French, I speak your language. But I tell lie, you do me damage. African bad girl, you so savage. Don't be selfish, girl, let's sit on my face. You got me on a little too crazy. Can't get enough from you, baby. Girl, you're so sexy, I must confess. Baby, every time I'm okay.